about hashing because it is important to understand when we override the hash code and the equals method in Java. So here on the slide you can see a hash table. A hash table essentially is just an array, and the idea of a hash table is to improve performance. So if we just have an array and we want to store objects in the array, we could use a loop. We iterate over the array and check where there's a spot available. We save the object. If we want to look it up, then we could iterate again and compare the objects using the equals method. And when we find the object that we're looking for, we can return if it exists or not. That would just be an array itself. And that would result in a performance of ON, since we have to always go through the entire array to compare and check for objects or available spots. Now with hashing, the idea is that we access an array always by an index. And accessing an array by index results in a performance of O1. So the tough part here is the question mark on the slide. That is in the cloud, and that is a hash function. So the purpose of a hash function is, given an object, the hash function will give us ultimately an index where that object is located in the array, if it exists. And then we can use it for saving the object or for looking it up or for retrieving it. So if we save it at that index that the hash function ultimately provides us, or we can check that index if an object exists. Now there's one more step involved here. So the hash function really just gives us a hash code, which is an integer code. And that can be out of the bounds of the array or out of the bounds of the hash table, really. So we have to map that hash code to an index. And the easiest way to do this is by taking the mod operation and mod it by the size of the hash table. So if the hash code is 105 and our hash table is 50, now if we do a mod 50, we would get 5. And then we use the index 5 to store the object or look up if the object exists. There are multiple properties that a hash function has to fulfill. First, it has to be deterministic. So given the same object multiple times, it always has to produce the same hash code, unless the properties of the object change. But if it's the same object with the exact same properties that are used for the hash by the hash function, it should produce the same hash code. The second, it has to run in constant time. If it doesn't run in constant time, if it runs in ON or ON square, it defeats the whole purpose of hashing, because that would be the bottleneck and would make everything slow. The last one it has to provide a uniform distribution along the hash table. So here, given a bunch of objects, we should get indices that uniformly distribute the objects along the hash table. Now, no hash function is perfect, and obviously when given more and more objects, there will be collisions. And a collision is when different objects map to the exact same index. So somehow we have to handle it. If we get object O1 and object O2, and they both map to index 3, for example, we have to store both of these objects at index 3. This is accomplished, or one way to accomplish this is by using a linked list for each element in the array or in the hash table, and then the linked list holds the objects. And so in this slide here you can see that some of the cells have multiple objects, but ideally there should be just a single object for each element, or no object if nothing is saved there. So now if we think about the whole process, given an object, we take the identifying properties of that object, provide it to a hash function. The hash function produces a hash code, which is just an integer. Now we do it mod the size of the hash table, we get an index, and now what we have to do is we have to check, do we have a collision? First of all, is there already an object at that index? If there already is an object, we have to be sure, is it the same object or is it a different object? If it's the same object, maybe we just update the object. So to determine if it's the same object or different object, in Java we use the equals method. And for the hash function, we use the hash code. So this is kind of the process in Java. We have an object, the hash code function produces the hash code, and later we run the equals method on the object that we want to insert or want to look up, and we compare to the object that is already there. So for example, the very first index here, index 0, we would do our object here, dot equals, and pass in this object, this object, and this object. If one of them returns true, we know this is the exact same object, we just replace it. If all of them are false and we want to store it, we just add another node on the linked list and store it at the end. And same if we want to check if an object exists, we call the hash code function. It gives us a hash code, and then the equals method will compare and see does it exist. If all of them return false for equals, it will be false, it doesn't exist. If one of them returns true, then it does exist. Now you might wonder why don't we provide a better hash function for the hash code, or a better implementation for the hash code function, hash code method, that it returns a different hash code or a different index. Now ideally that would be the case, but no hash function is perfect, and somehow we always have to take into consideration that there might be a conflict. So in Java, all of this is done underneath the hood when you call hashmap.put or hashmap.containskey. This is all done for you, but you have to be aware that these two methods are called, because if you're not aware of this, you get a different behavior, where you get maybe a lot of collisions or different hash codes for the same object, or for different objects with the same properties. So you have to be aware how this whole process works. Now here's an example. Let's say we have an example book, and this is our class. We don't want to use all the properties in the hashcode function. We want to use the identifying properties. So in this case, it would be title and author. The price of a book can fluctuate. It could get on sale. Maybe there's high demand. The price increases. So we don't want to use the price, but the title and the author will always stay the same for the book. So we use these two properties as input to our hash function. And the identifying properties are also referred to as search keys. Now the hash function produces a hash code, which is just an integer. We use that integer, mod the size. If our hash table is very, very small, like in this example, we do mod 5, and we get 3, and we store the object there. Or if it's a contains key method that we call, we look if the object exists. So this is all about hashing. I hope that makes sense to you. And you can watch my other video about the hash code and equals method and how to implement both methods. Thank you.